Hello everyone, welcome back to another video. This is Pranav Shastri from Sri Venkateswara College of Engineering, and in this video we'll be talking about uh, the support vector machine model. So support vector machine or SVM is one of the most popular supervised learning algorithms which is used for classification as well as regression problems. So primarily it is used for classification problems in machine learning, and the goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. So this is the best decision boundary called the hyperplane. So what we do is we just take a plane on which we have two axes x and y, and on which we have certain data points that are to be classified. So for the classification to happen, we create a hyperplane that is a line that segregates the data points best according to its class. So uh, the most efficient way is the best hyperplane. So SVM chooses the extreme points or vectors that help in creating the hyperplane, and these extreme cases are called support vectors, and hence the algorithm is called a support vector machine. So one of the key advantages of SVM is its ability to handle high dimensional data with relatively small small sample sizes, and this makes it particularly useful in applications where there are many features but few examples, such as image classification or text analysis. So this is the working. Like I said, there are two diagrams here, and you can see on the XY plane there are few data points which are to be classified, which are of different classes. In the right one, you can see there are objects of two classes, that is stars and circles. So the best hyperplane is the one that divides those two classes most efficiently, and in this case, you can see that the hyperplane B. There are three hyperplanes, as you can see in the scenario one. We have three hyperplanes, and in the right hyperplane, you can classify stars and circles. And so, the selected hyperplane that segregates two classes better is the one is the one that performs the best job. And in this case, it is B. So let us come to the scenario two, where we have three hyperplanes A, B, and C as well. So and all segregate the classes well. So the thing is, when you have three hyperplanes with when all perform better, so how do you identify which one is the best or which has the highest accuracy or efficiency? So in this case, the robustness margin comes into play, whereas the hyperplane. So as you can see, maximizing the distances between nearest data point of either classes and hyperplane, which helps us to decide the right hyperplane, is the distance is also called margin. So coming to this slide, you can see that the margin for hyperplane C is high as compared to A and B. So hence we named the right hyperplane as C. Another lightning reason for selecting the hyperplane with higher margin is its robustness. So robustness provides more accuracy and better data segregation. So if you select a hyperplane having low margin, then there's a high chance of misclassification of the data points. So let us take a example of binary classification, that is through our code. So in Python, you can import the scikit-learn module or sklearn module. So the first code is from sklearn import support vector machines. That is our library, and from the module selection we can import test train split. That is to split our data to training and testing sets, and the metrics to show out the accuracy score. So here we need to prepare our data, that is in X and Y. So you can see X as the feature matrix and Y as the target variable. So feature matrix is our X, and we split the data into training and testing sets using our test train split function that is supported through our sklearn module. And here the test size is zero point 0.2 and the random state is 42. And creating SVM, so creating an SVM classifier, that is, we take a variable named classifier and we name SVM dot SVC, that is our kernel, to make a linear support vector machine or a vector. So here we train the classifier on the training data, that is, we fit the data into X train and Y train sets, and to make the predictions, we use the predict function and we take it under the variable Y predict, and using classifier dot predict X test we train the test data, And to calculate the accuracy of the model, we can just use the accuracy underscore score function, which stores the accuracy, and it can be printed out using the print accuracy function. So, pros and cons of SVM. One of the main advantages of support vector machines is its ability to handle high dimensional data with relatively small sample sizes. And as mentioned earlier, SVM can be used for both classification and regression tasks. So it has a solid theoretical foundation and can provide good generalization in performance. So, however, SVMs can be computationally very expensive, and especially for larger datasets, uh, as you might have many classes and you might need many vectors to be plotted, and for these kind of data sets, it is very sensitive to choice of kernel function and parameters as well, so which can affect the performance of the model. And finally, SVM can be difficult to interpret due to complexity of optimal hyperplane. And there might not be one optimal hyperplane, there could be many, and choosing nearest one can be a bit difficult to find the most optimum one. So SVMs can handle both linearly separable and non-linearly separable data using different kernel functions. And the kernel trick allows SVMs to implicitly map the data into a higher dimensional space where it becomes linearly separable. This flexibility enables SVM to capture complex relationships between features. And SVM creates complex decision boundaries, particularly with non-linear kernels, and this can make it challenging to interpret and understand the model's inner workings. So, unlike more transparent models such as decision trees or logistic regressions, SVMs are pretty complex in decision boundaries. So, this is it for this video, guys. Thank you for watching the video. Please do leave a like and subscribe to the channel.